Okay, does anybody have any questions before we start? Oops.
I have a little question.
Okay, so for start, yeah?
Like, I don't know, whether the group and companies, does that matter?
It probably doesn't matter, but let's look after class. I assume that one was a lot cheaper. I don't know if it's a lot cheaper, but cheaper usually this student. Sometimes they make minor edits. They always make some sort of edits so that they feel good about themselves when they sleep at night, but rather than just putting international version, but it's a total price discrimination scheme, so. So, I'd like you all on your notes here to draw what a utility function looks like with beer on the horizontal axis and utility on the vertical. Get your papers out.
Say that.
We're going to be doing a little utility work today. So, total utility function, this is principles of micro. Beer on the horizontal axis and utility on the vertical. There we go, next level. I don't want to be all crooked. First person with the right answer, lift it up, say you got it, and I will look at it, an extra credit point.
I got it.
Okay. What's this?
Utility.
Wrong.
What was the question?
Right. Wrong. Well, okay, I'll accept that. Okay. So, Lawson, you had them flipped around. Beer on the horizontal axis.
Oh, crap.
Otherwise, you were real close. Okay, so why does it have the shape? Both Lawson and Bryce had a increasing function, but what was true about the slope?
Diminishing marginal utility.
Good, diminishing marginal utility, right? So the law of diminishing marginal utility gives rise to a number of things in a number of different ways. And so that's kind of some of the stuff we're going to start off with today. So it reflects the relationship of marginal utility as well. So if we're measuring the quantity of beer and then utility here, the total utility function goes like this. Now Bryce, the reason I hesitated on Bryce is he kind of did this on me, which is theoretically possible, but we don't always do that tail. So Bryce, I want you to justify yourself.
So like at some point, like say if it's beer, at some point you're so drunk that that next beer is actually hurting you rather than helping.
Okay. Yeah, and beer is probably the best one for that because your judgment gets distorted. Most goods we probably wouldn't necessarily describe it that way because what can you do as a consumer once you reach that maximum point as it's shown there?
Save it.
Save it is a possibility with a more complicated model, right? You could save it for the next time period. What else? Sell it, throw it away, don't do it, don't consume the beer, right? So the beer is kind of because you get a little irrational maybe, and so that might be playing a role in here. So the point is that yes, if we were forced to choke down that last Oreo cookie, which, did one of you do that type of project for their video in principles class for me? You remember the video? Well, not all of you saw it, but I shouldn't be I'm not going to waste class time on it. I'm just going to tell you. The guy ate 50 chicken nuggets. Some of you might have saw that video here in Ottawa. They went down to the McDonald's in a self-reported utility, and he was basically turning green, honestly, at the end. So that was pretty spectacular. That is on I think on the Russ Econ Rocks YouTube channel, so you can check that out on a different time. But yeah, that's kind of fun. So All right, so this is not a fair thing to do theoretically, but we're on this tapping a common labor pool, and this is one of the advantages of firms clustering, right? So firms cluster together. We have workers that have similar skills, and we can tap into them, and so that's kind of a nice thing to do. And we're going to look now at the benefits to the workers perhaps as well. So here's the reason I did the beer thing, is that we can also look at it in terms of income. And this is where it's not totally fair when it's income, because we can use income for a lot of things. But does a rich person, a high income person, have less utility per dollar than somebody else? Certainly can't do cross-person comparisons. But the shape of their utility function might be a little questionable when you're using income as opposed to a good like beer. But conceptually, we can live with it, right? That maybe it would be acceptable to think of the last dollar used doesn't give you as much satisfaction as the first dollar. But if if you're making $300,000 a year and you make an extra $20,000, you could have a lot of fun with that extra 20 too, right? So that's what I mean. It's different than beer. You with me on that? So it's a little bit of a sleight of hand that economists do as an assumption to kind of work out a model, but it's a little fair to call it to question. All right, so let's now think about workers being mobile between two cities. What is the required to achieve a Nash equilibrium in a workplace choice? How can we use the concept of certainty equivalence to translate the expected utility of the risky, isolated job into dollars? Those of you who had intermediate econ, which is not all of you, we did a little bit of this, but I assume this is going to be a little foggy for all of you. But it is kind of similar to how the insurance market works. So you might see some things from other classes come through. So certainty equivalent. So we have an unknown income between the two cities, right? So we might get lucky and get 100. We might have the 144. So one city pays off 100, one city pays off 144, and that translates into these happiness numbers. If I have $100 worth of income, I have 10 units of happiness. 121 gives me 11, and 144 gives me 12. So that's kind of our starting place, just to kind of talk about this related to beer. Any questions so far? Just kind of teeing it up. All right, so suppose we've got a 50% chance of being fired from either firm. Maybe it's because the industry we're in kind of comes and goes. Maybe it's Silicon Valley, we're at a startup company and one might start up and another one might fail, right? So we have some uncertainty with our job prospects. So an isolated firm, the wage is 144, and the switching cost is $44. So if we have a favorable outcome and we get to keep our job, then we get 12 units of happiness. So if we get the bad outcome and get fired, we have to switch and move to another city, and so we end up getting the net income of 100 with the switch. So what is my expected utility when I have, and by the way, what we're doing here is we're looking at two isolated firms versus clustered firms. Firms that are located in the same city versus being far away. So that's what this whole switch cost thing is. I expect 144, but if I get fired, I incur a cost of 44, and so I actually only get 100. So what is my expected utility under these circumstances of, I got a 50-50 shot of basically netting 100 or netting 144? Jonathan?
You just sit right in the middle at the 11?
Okay, at the 11. So why is that? Kind of talk me through that.
Well, because you have a 50% chance of keeping 12 and a 50% chance of getting knocked down to 10. So
Okay, so let me transfer what you just said into the foreign language of math. So the expected utility equals, you got a 50% chance of getting how much?
12,
12, and a 50% chance of getting
10.
10. Expected utility of 11. Okay, so 50-50 shot, we got expected utility of 11. All right, cool. So what is the certainty equivalent? A 50% chance of getting fired from either firm, uncertain utility of 11. So everybody's with me that that's uncertain utility of 11. It's expected utility of 11. What are we really going to get? 10 or 12. So that's always important to keep in mind. So then what would be our certainty equivalent? 10? No. So we're for sure going to get 10 or 12, but what's equivalent to getting 11 with certainty? What income would I accept?
121.
121. So from this declining utility function, now notice that the difference between 121 and 144 is different than 100 and 121 because of the diminishing utility, right? So our certain income of 121 would get us the same amount that we would be rolling the dice. So that's our certainty equivalent. All right, so what would happen? The Nash equilibrium, if firms are able to relocate, would be to cluster. Why? Why would a firm want to relocate?
Maybe try and get some workers from other firms that don't get fired or don't want to work there anymore.
Yes,
So the labor pool?
the labor pool is better there, right?
Gets rid of the switch cost.
It gets rid of the switch cost,
Lower wage.
lower wage. So all of what you said kind of links together down to, from the company's perspective, of a lower wage. So what is the expected wage that the company is going to pay under those circumstances?
100.
120. They got a 50% chance of paying 100 and a 50% chance. I'm not following this function. I'm thinking in terms of the company's hat. 50% chance of 144. So what's my expected pay?
121.
120. 50 plus half of that. So average between the two, 122. So if I'm a profit maximizing company, this clustering thing is actually kind of nice. So it's a win-win situation, making it a Nash equilibrium, that the workers are indifferent between a 50-50 shot at that, and the company's actually saving a little bit of money compared to what they would expect. All right, so that gives us incentive for the firms to cluster. I think I got one more. Oh, no, I don't. Okay. So let me field questions. I thought maybe I had one more slide on that, but I didn't. I think that looks like a good spot to do a little problem to check yourself. So if you have your book with you, you can turn to, and this will be your first test, Carlos, of that book to see if they do the problems different. So number 2.
Which page is it?
It's 61 on this book. I don't know if it'll be that. It's at the end of chapter 4. So consider the model for labor pooling shown in figure 4.2, which was the one we were just looking at. As before, the utility function is now the wage raised to the 1/2 power. The isolated wage is 144, and the switching cost for the cluster, let me try to organize this in the center here. And the switching cost for the cluster is 0. Suppose the switching cost for the isolated site increases to 80. Illustrate the implications for the expected utility and the certainty equivalent of the isolated job. So switching cost changes to 80. The function was utility raised to the W to the 1/2. So why don't you guys kind of work with your neighbor, see if you can put that together. I'm just going to rewrite it in the margin since it's on the other page. The utility as a function of the wage was equal to W to the 1/2 power, basically the square root of the wage. The switching cost is 80. Feel free to move your chairs if you want to shuffle around a little bit. We'll just kind of work this one out. Kalen and McKenna.
The same, but instead of going down just 44, we're going to go down 80, so it's somewhere we'll just do. Oops, too long. So it's 144 minus 8 because of the switching costs.
Yeah, it was just the switch cost. So the 144 is still the high end number if you didn't have to switch because your company didn't use a lot.
So those guys are covered.
Okay, so you know where you're going with this? So the old switch cost was 144 minus 44 is what gave you the net wage of 100. And so now it's 80, so it's going to be even smaller. So kind of rework the problem now with 144 minus 80 being the switch cost. Yeah. I mean, you're on the right track, but this is the wrong number, I can tell you. So the utility function is the W to the 1/2.
Yeah.
The square root of the wage. Right, so now you're going to have to recalculate that. Is your, what
sending
you
it
do
all
there
right
with
now.
your numbers?
144 subtracted 80, that's just switching costs.
Switching costs is, remember how on here was 44, so you just take 1.
To give you 10 is the utility. I didn't look at the answer, so I was just surprised that it was still 10 again. But yeah, okay, so then it's 10 and you're back to the 100?
Switching costs for the isolated site.
So is this still a 50-50 shot type scenario?
So the only thing I'd say, Bryce, is, and this goes for everybody, look at the question, and I want to be able to look at your paper and say, the implications for the expected utility is this, so make sure that's really clear. and the certainty equivalent of the isolated jump.
So it's 50%.
Like, don't make me assume that that I'm reading, your stuff on your axes or whatever. Yeah. Where'd you get that number? 32. It's not times. This is raised to the 1/2 power.
Oh, that's true.
That's the square root. So the square root of 64 is 8. So the what yes. 10 is the expected utility, right? So here you should be putting,
Yes, someone.
you can do a shorthand like I did there, the expected utility.
That's what I'm about to write
Kind of
down.
identify your
That's
key
not
numbers.
together and divide by 2. So it's,
Yeah.
it's right in the middle.
Okay.
Okay.
Yeah.
So now you're gonna find the expected utility,
Okay.
because you're either gonna get 64 now, or you're gonna get 144. So your happiness is gonna be the 50% shot of getting this or this. Right?
What's greater than equals.
Okay, looks like most of you are there.
It's gonna be between 8 and 12, so it's still.
So this is the utility function of the w to the 1/2 square root. And so we have the 140, oh, whoops, not the 144, well, 12. And now the switch cost ends up getting us back to 64. Square root of 64 is 8. The expected utility happens to be what we had before. 50% of 12 plus 50% of 8 equals 10. So the expected utility is 10, which is what we had before. It's still centered right there. And that gives us the 100. Oh, that's not what we had before, is it?
No, we have.
No, sorry. We had the 10, but the 10 was the lower bound. That was throwing me. Okay. So yeah, now we have a different expected utility number of 10. And so that is our certainty equivalent of 100. So basically that, if I was offered 100 in a cluster, that would be the weighted average of my utilities. It would leave me just as happy. Okay, so the only thing that I don't like about this problem is, yeah, go ahead, Carlos.
How do you get 100?
The 100 was off the square root, so 10 squared, undoing this, you're squaring the utility. 10 squared is 100. So this function is, the square root of 100 is 10, so if you know the 10, then you're squaring 10 to undo the utility.
So that's kind of like how you check, kind of like double checking if you're right.
Yeah, so, well, it's more than double checking. You need to do that to calculate your certainty equivalent. So you're doing this, which I wrote up there on the board, the w to the 1/2, which implies w equals the expected utility squared, which is, this side squared, this side squared. We're just undoing the half part. Which I know, working with exponents, we don't do that every day in every class, so that's a little math on the math side. We gotta have some of those exponents. Doesn't happen too much, but a little bit we'll do it in this class. Any other questions? Let's see, I was gonna say something before, what was I starting to say?
I don't like something.
Oh, yeah. The thing I didn't like about this was that, in reality, this is for a risk neutral person. And most people are risk
Prone?
prone, not the word I'm looking for, risk averse, right? So that's where the insurance market comes into play. Insurance companies are risk neutral. They'll take that gamble, right? The expected utility. I might get I might get 8, I might get 12. I don't know what I'm going to get, but on average, I'm going to get a payoff of 10. Whereas people would rather have the certain payoff in general. So somebody would say, instead of getting 8, somebody might say, give me 9 units of happiness, and I don't want to play this. I don't want to play this gamble, right? And that is kind of what we're doing, by the way, by putting the cluster. So when I said, here's the part that doesn't come out from the author. Remember when I said it was a win-win situation? The company gets to pay a lower wage, and the employee is no worse off. The employee is actually better off because they're probably risk averse. And to take a certain 100, they would probably take 9 units of happiness, right, or something. If they knew they were getting the pay with certainty, that's even to their benefit because they're risk averse. Now, just a little tweak. Probably, maybe I shouldn't have even opened my mouth, but okay. So good. So we have that. All right. Back to any other questions or comments? All right. So skills matching. So when we open up our company, we're going to incur some training cost because the person that walks into my door on day 1 doesn't know everything perfectly about the jobs, right? So there's always a little bit of on-the-job training. Some stuff that's not very complex. You know, one day training for an hour. This is how you drop French fries into the fryer. Bring them up after 3 minutes. This is how our process works, right? So something pretty simple like that. That training cost period might just be an hour. In other jobs, it might take you 6 months to ramp up. It might take you a year in some cases to really get into the groove. The more complex it is, the more difficult that'll be. Okay, so here's our model. We've got two situations, one with 2 firms and 4 laborers versus 3 firms and 6 laborers. And when we have more people concentrated and firms clustered together, what's your gut feeling saying? Is there going to be better at skill matching or worse? Better, right? So that's our kind of expectation going into it. So that's kind of helpful to look at this. So this model's kind of funky. And here's how it works. We've got the triangles are the people located at these addresses. And the companies are located at these addresses. I'm sorry, I picked the wrong one. The firm is at 1/6 and 5/6. And so the mismatch is the distance that the employee is from the company. So 1/3 away is 2/6. So this guy is a 1/6 mismatch for this company. And this guy is a 1/6 mismatch for this company. And same thing here, 2/3 is what, 4/6. So we got 4/6, 5/6, 6/6. If we put it into 6, it'd almost be easier if the author had it that way so we can get the fractions down. And so the mismatch of this person's skills and what this company needs is this distance of 1/6 for there. Okay, questions or comments on that part? Downstairs, we have firms closer together. So notice our scale was this distance 0 to 1. And so now we've taken that distance and we've put more firms into the city, into a physical space. And so now there's 3 firms, and the distance of these laborers now is 4/5, which is 8/10, is 1/10 away. Right? So the more tightly packed, there ends up being a better skills match. All right, so that's kind of just the setup of the model. give this a read. Okay, so what's the math going on here? So are you guys seeing that?
Because that skills gap, the 1/10 of 30 is $3. Same with the 1/6 of 30 is $5.
And this is in the smaller city, right? So we're basically multiplying the distance, if you will, times the training cost. The training cost is the same whether you're in the big city or the small city, the upstairs panel or not. And so the more packed in we put people, the higher the population, then the lower the training cost is kind of the point it's trying to get across. Okay, so this little formula for the model illustrates the agglomeration, the benefits, as the city grows. So M is the result, like the 1/6, the skills mismatch. And this formula, 1/2 times n minus 1, gives us the distance of the skill match, according to the population. Questions on that? Can't remember if there's one more thing here or not. There's not. Okay, time to do a problem. Number 4, model and management and extreme makeover. In the model management industry, firms supply human models for advertisements. Models vary in skin color, which is measured on a line of unit length. Skin color can be modified with makeup, and the makeup costs are incurred by the firm. Each firm enters the market at an address on the color line, and each firm manages 2 models. Suppose that the cost of an extreme makeover, the cost of going from one end of the color line to the other, is $90. Illustrate the determination of makeup cost in a city with 4 models and 2 firms, a city with 6 models and 3 firms. Include the values for the makeup cost per model. So we've got the 2 cities again. We've got the extreme makeover cost equal to $90. And then we've got a city, let's just call it city A, with 4 models and 2 firms. And 2, a city with city B with 6 models and 3 firms. Illustrate the determination of makeup cost in a city with 4 models versus a city with 3. So I wrote down the notes of pretty much what you need from the problem, so I'm going to put the Notice the author kind of gave you the same setup as what we had here. The model is the 0, 1, by the way. So those are kind of the anchoring spots, if you want to think of it that way. So this problem is going to basically work out very similar to what the other one was. I'll give you some time to noodle that. Yeah, it's probably a good idea to rewrite. I see some of you doing that. So just kind of rewrite this because it really is the same with the 4 and the 6. For the model, we're basically always just evenly separating out the firms, or not the firms, but the labor is scattered out there. And it might be good to use this formula just to kind of experiment with that. So as soon as you get an answer, tell me what you got for city A and city B.
For A, I got M equals 2.5, or 1.5, sorry.
M equals 1.5, so that's 3 halves.
Yeah.
Sometimes it's easier to keep in fractions, sometimes not, but okay. I'm just gonna put it down. So that's the M. That's the skills mismatch, but the problem asks for the makeover cost, right?
But is that one is 1.5?
So it'd be $135, wouldn't it be?
So we've got illustrate the determination of makeup cost in the city with 4 versus the city with 6, including values for the makeup cost per model. So you said this for A. We can just kind of check real quick what Lawson did. 1 over 2 times, what's N?
4.
4 minus 1 equals 1 over 4 minus 1 is 3.
6.
3 times 2 is 6.
And that's
So I'm not sure where'd you 1.5 come from, or
it's 0.16. 0.166.
point what's if you do a decimal, but we can keep it fractions.
Oh, I see what I did wrong.
Okay. Is everybody getting the 1/6?
Yeah.
And then for the big city, I guess if we're gonna do B,
1/10.
it's 1/10. That's the same answers we had before. Nothing changed. It was the 6, and that's the population. But it's good to kind of use that formula to see what they did, because it could be different populations, right? A different problem could have a population of 10 or something or whatever. And then we just take the 1/6 times the makeover cost, so M times 90 equals 1/6 of 90. And so what did you guys get for that?
15? Oh, no, sorry.
Yeah, 15.
15? So 15 bucks in city A, and what'd you get in city B? 9 bucks. So the bigger city gives you lower makeup cost.
What was the bigger city one?
The bigger city was B. So it was 6, the population of the city, the N is the number of employees available. So it's the 6 and the 4. Okay. So, knowledge sharing was number 4 on the list. So we talked about grabbing a beer at the bar after work. So there could be informal mechanisms in place. It could be within the industry, which is the localization economies. So that's localized to within the industry. We're both doing game apps or something, right? Versus across industries, this one does game apps, but this one does some other computer programming in a different area. So, where have you experienced knowledge spills on campus? Knowledge spillovers is what we call them. Where do you get some knowledge spillovers?
Yeah.
Where? The caf, yeah. Kind of like the bar. Where else? Library, sure. There should be lots of places, right? Where?
Teams.
Teams, okay, within your teams. Where else? What do we like to do at Ottawa during your freshman, sophomore, and even junior year?
Orientation.
You gotta stay in the dorms.
Oh, I see.
So the dorms are potential spaces for knowledge spillovers, right? 2 different majors would be kind of equivalent to maybe different industries. So somebody's doing chemistry, somebody's doing econ, you both are in college algebra, right? So you could almost liken it to that. So different ways where we put people together. One of the reasons we do that in Ottawa, as you know, is to try to make some money off you guys. But there's also good research that shows colleges that have you stay at least your freshman year, but then other years too, retention rates are higher. So you guys tend to bond with other people, and then even if you hate your professor, McCullough, you like your roommate or you like people in the hall, and you hate the person you have this term, but you met this other cool person that you're going to room with next term, right? And so it actually creates better retention, which is also to the bottom line of Ottawa University. If you guys stay here instead of transferring away because you're mad at life, right? So even though we're a non-profit university, we very much care about profits because that's what makes this place sustainable, right? So non-profits, don't buy into the myth that non-profits don't care about profit. Non-profits need to be profitable to be sustainable. Now that can come through donations and other sources, right? But they very much are running the same income statement and balance sheet that for-profit businesses do. It's the same on the money side. Okay, so this is a quote. I guess I'll read it. You guys can read along or whatever. This is from Alfred Marshall. He kind of is the guy that invented the demand and supply curve, by the way. So 1920, he's one of the guys that put some principles of economics together. When an industry has chosen a locality for itself, it is likely to stay there for long. So great are the advantages which people following the same skilled trade get from a near neighborhood to another. The mysteries of the trade become no mysteries, but are, as it were, in the air, and the children learn many of them unconsciously. Good work is appreciated. Inventions and improvements in machinery, in processes, and the general organization of the business have their merits promptly discussed. If one man starts a new idea, it is taken up by others and combined with suggestions of their own, and thus it becomes the source of new ideas. So way back when, one of the kind of early pioneers of economics kind of had this agglomeration idea. He was kind of capturing the knowledge sharing and how important that is in the development of business, the economy, and society. So lots of things coming up, right? More golf courses, more fishing holes. The two spouses, one might do horses, one might do economics, right? So lots of benefits to urban size being bigger. So this is kind of maybe a wild card that maybe you weren't expecting. Agglomeration diseconomies. So what happens if there was workers that were increasing in cluster? What would be the effects of an increase in population density? What would be this clustering concept with some negative aspects? Can the city just get infinitely bigger and it's always better? Too many workers, not enough jobs. Okay, well, we're hoping that that'll be, some of it would shake itself out somehow, but yeah. Maybe there'd be timing problems. Jonathan?
They make the whole city mad and everybody goes on strike.
What would make them mad?
Just lower wages or stuff like
Higher
that.
taxes.
Higher taxes? Okay, so taxes might play a role as it gets more congestion. Mackenzie? Not to be able to produce enough food?
Yeah.
You know, I think you could run into some sort of constraints that would be those short term. In a free market anyway, if they're running short of food, then they would be willing to pay higher amounts to get food brought in, right? Or to produce more food. So that would be the market mechanism. However, you kind of bring up the whole thing with the price going up. Some things might start to get more costly in the city because of that, right? Now, nobody's brought up the one thing that I think kind of sucks about big cities compared to living in little old Ottawa.
Space.
Living space is one we'll talk about. Driving, congestion of cars, right? That adds. So we'll talk about congestion being a negative effect. So lots of things that come with density that could be some problems. Okay, so we've got some trade-offs going here. So as more companies come in, the companies compete for these workers, and in order to pull them away from somebody else, they got to bump up the pay. So we might have some costs going down, like we have with the localization economies, the intermediate input, like the button supplier to our dressmakers or something. But we might have some other things going up due to congestion or other things. So if we start with isolated firms, how many firms are going to cluster together? That sounds like a profit maximizing proposition. So check it out on that top panel. The idea that labor costs would be going up because firms are bidding up wages for workers. Workers also maybe demand a higher wage for other more costly living expenses. But this was like a Hollywood deal. That's what the props. So props for Hollywood sets. So as a prop producer, you guys have seen, you know that they use like, you've seen maybe some shows where the same props for a telephone or different things that are in a TV scene or a movie scene are reused for them, right? So the number of firms in the cluster, as that goes up, then the prop cost goes down. If it takes you know, a couple $1,000s to make some prop for a movie set, and it's a one and done, well, you're gonna have to pay kind of the whole thing. But if I can rent that out to multiple places, all of a sudden maybe I can bring the prop cost down to you rent this thing for $100 for a day or something, right? As opposed to spending $2,000 to build the prop on the front end. Okay, so that's what's going on there. So total costs are going up. And we want to think about the isolated firms. So the way this model's working here is this is the number of firms in the cluster. So a cluster of 1 is an isolated firm, right? And so the profit function, holding revenues constant, looking at that cost, the total cost is $72 for 1 firm to be operating there. And then what happens is if 2 firms come in, the prop cost cut in half or dramatically drops apparently. And so now we have the ability to make more money with 2 firms. But eventually the labor cost is going to win out because that's going up and possibly at a faster rate, but compared to prop cost has got to kind of level out at some point. And so as that happens, we have more firms coming in. So these firms are saying, should I move to Hollywood or should I operate in isolation? Well, wow, the costs are lower, so I'm gonna operate in Hollywood. I'm gonna go to Hollywood. But as more people come to the cluster, then the labor costs start to offset the prop costs. And so eventually, the companies that are entering the market are gonna be indifferent between joining the cluster and operating in isolation. Because if they now join the cluster, if the 6th company joins the cluster, they could have made more by operating in isolation. Questions on that? All right, so then this last one's just kind of thinking about the gap, profit gap. They just dropped the A to 0. So we get back to having a normal profit. So in competition, this is really addressing cluster size. What our long run prediction would be is that companies operating in a cluster would earn a normal profit, right? It's eventually going to, the benefits of clustering are going to run thin with diminishing returns, and there'll be a optimal profit maximizing size of the cluster. All right, questions or comments there? All right, so this is the picture that, by the way, some of what I just worked you through was from the old edition that I like the way they light it up. Your book kind of starts here and then talks about it. So, but it's the same concept of, it's just that middle panel that they're showing here. All right. So, why cluster again? Why do firms cluster?
Increases profits and lower wages.
Higher profits,
Lower costs.
lower cost, right? So that translates into profits. And what's driving that is the intermediate inputs, the labor pool, better match of workers and skills, and the knowledge sharing are the 4 things to kind of review. So the end of the chapter looks at employment and clusters in the real world. And so this is from the old textbook that still had some interesting data, and then there's some from the new textbook as well. But video production and distribution, 44% of the employment in that industry happens in LA. So 44% of the employment. Now this was back in 2004, but I suspect it's not much different now, but I think there'll be an update in the other one. So there's the employment and then the metropolitan area. So that's pretty big. This is a cool graph that they got rid of in the new edition, so I like to keep it because it's pretty cool. So it's a 3-dimensional graph, and this shows the production of carpets and rugs. And so these are areas where carpets and like brand new carpet in your home or whatever, where does that stuff come from? It's likely coming from Georgia, right here. And so that ends up being 41%. So what's kind of cool about this 3-dimensional graph is you see the geography, and then it shows the percent of the industry coming from a specific place. So kind of in a snapshot, shows you that that's a pretty big cluster of jobs over in Dalton, Georgia. Costume jewelry. So that's another example they run through. Where is that happening at? Rhode Island. So right near New York, all the fashion area, 55%. Notice that there's a decent little cluster over here in LA, and I think that's, what is that, New York is the other one. And then a little bit down in near Disney apparently, right here. We need some costume jewelry down there. So, economists study this stuff. Maybe your papers would be on something like this, if that sort of thing interests you on these spillovers. How the heck do they measure a knowledge spillover? You having beer with your buddy and talking about stuff. How would a researcher go about concluding knowledge spillovers? Jonathan?
They ask people questions about stuff that's not in their field and see what they know.
No. Great thing to bring up, but that's not how they would do it. And the problem is with something like that, we don't want, a knowledge spillover is something technical. So let's kind of drill down on that a little bit more. What's technology?
Innovation.
Innovation, okay, what else? Is this technology?
Yeah.
Or is it a phone?
Both.
I mean, would you really say this is technology? Or if you're really careful with your words, we say that sometimes, like, this is the new technology. But it's not really true, is it?
Yeah, technology, isn't that anything that makes life easier? Or tools that make life easier?
So that's some of the benefits from it, yes. But what does it do? What does a new technology allow us to do? What's productivity? How would you define, give me a formula for productivity. Productivity.
Same output with less input.
Same output with less input, that would be one way to do it. How about a formula? So Carlos is onto the right thing there. Same output with less input. I like that. And let's just make that a formula. Let's see if you can put on your formula goggles, or somebody else can. So productivity, let's just say what we're measuring. We're measuring productivity, and that is equals, there's our formula sign. We got equals. Take me away from there. Carlos says, and I agree, same output with less input means an increase in productivity.
Yeah.
Correct? I agree. Put that in the formula. This is a formula I'd like you guys to have right off the top of your head. That's why I'm going over it. Productivity. I mean, Carlos is almost saying it. Output minus input, let's start there. That's wrong. But let's do that, Julian. Number of output minus number of input. It's wrong, but I want to do it anyway. So I make, give me a good, any good, Julian? What do I make? What do I make? Pencils. So I've got 10 pencils, and I use 3 hours of labor, and so my productivity is 7. So this is labor, number of people or hours, labor hours, and this is number of pencils. And 10 minus 3 is 7 is absolutely wrong. It makes no sense. So let's work with it though. Why would that, I mean 7? 7 what?
That must be output equals
It's gotta-
input.
you have to
times-
Can you subtract these two things? Is this apples and oranges type of problem?
It's like,
Right, it doesn't really make sense, right? So it's a great start though. Thank you, Julian.
you have to do like
Thank you for your courage.
10 pencils, so like 10 PD minus 3 labor. Or minus.
I like Lawson's better. No minuses. What do you want to do? Oh wait, was that using? Sorry. Divide it. Divide what? What by what?
Output by my input.
Excellent. Now this makes sense. I've got 10 pencils with 3 units of input gives me 3.3 pencils per labor hour. Every hour I put in, I crank out 3.33 pencils. Okay, so let's make sure we cross off this formula. I don't want you guys have that in there.
But that's the actual formula?
That is the actual formula, yep. Number of units of output divided by number of units of input. Sometimes it can take on some different forms if we're doing, I don't know, percentages or something, but this is the good one to hang your hat on. Okay, back to my main question. What is technology? What does technology do to this?
It makes it bigger.
Increases output,
Increase productivity.
Decreases input.
decreases input, or both?
Both.
So it increases productivity, right? At the end of the day, when there's a technological change, does the pencil, I don't have a pencil, but I wish I had that for illustration purposes, so use your vision.
Yeah.
Oh, there's a pencil. Does this look different than it did in 1955? I'm glad you have a real one. Do you think, does that look a lot different than what it did in 1955? Maybe you've seen some old stuff? No. So my point is there technology that's impacted this?
It is.
If we think 1955, you think there's been a few machines, maybe a computer was invented or something that helps us make this better? And so we've become more productive. Instead of 3 labor hours generating 10, maybe, again, I'm just making up a number, but it's 100. Why? Because there was a new invention, there was a new technology, there was a new process. So technology is information that was productive. It helped us make something else, right? So technology is embodied in the products that we have. Technology is in there, but I can't really point to it. It's just knowledge of how it's changed. So our output, and possibly our inputs, by the way, embody technology. And technology is like a current information stock, right? We tend to add to the information stock over time, and that helps us be more productive. Okay, now, knowledge spillovers. Is knowledge information? Yes. In this context, we want that spillover. Do we want that spillover to just make sure you're having fun with your buddies if you're a company? That we really will take it important that you have good beer conversations about your, the girls or guys that you're chasing, and that's really important to us as a business. Is that why we care about knowledge spillovers from the business perspective? What do we want those spillovers to do? Innovate, increase productivity, right? To tie this back to here. So a knowledge spillover is knowledge sharing that leads to higher productivity. That's what makes it a spillover in this context, in this class, right? A knowledge spillover is knowledge that's not contained within one company, but once shared, possibly at the bar, helps other people do better too, right? Just like the things we've been talking about. Okay, back to my question then. How do these guys go out and measure that? How would we know whether we have some spillover effects? Because they're claiming something big here, notice. Knowledge spillovers cause firms to cluster and increase the number of firms, firm births, and total employment. They seem to happen in the most innovative industries. That's kind of a little hint there. And they're highly localized. And knowledge spillovers are prevalent in industries with small competitive firms. So what are they kind of measuring, perhaps?
Maybe
Use
they're
your imagination.
measuring the new firms or the size of the firms that are there.
Yeah, so that's one way they do it. So the new firms thing is just, how many firms have evolved in this particular geographic area, right? So number of new firm births would give you the idea of clustering, right? They're all this place versus New York versus Kansas versus other places, where these firms are located. How are the ones in isolation doing versus the ones that are clustering? And we can measure maybe the number of startups in a place. Okay, that might be one way. Did you have something else to comment or question?
By looking how much increasing productivity is between the firms that are
Good.
better.
That's the other thing they're going to be looking at is what is the output, right?
Yeah.
So that a lot of times will be measured in dollars, right? So if they're making goods that aren't identical to each other, but they are substitutes with each other within an industry, they can look at the dollar volume of output in Hollywood or the dollar volume of output in Silicon Valley versus the dollar volume of output in Denver, which is another little hub, by the way, for some of that stuff going on in Texas. And so you might identify places that are bigger clusters through number of firms or number of firms in that industry, and now you can compare the productivity differences between the two. And if this one seems to be higher than this one regularly, maybe we can use some statistics to say that that must be attributable to the knowledge spillover effect. The fact that these guys are close together, there's some knowledge sharing, and that is likely attributable to these knowledge spillovers. So that's kind of a researcher's approach to trying to measure some of this stuff that might not always be easy to do. Andrew, did I see a hand up? No? Or somebody stretch or, okay. James?
I was gonna just say what Lawson said.
Okay, so you were just gonna comment there? Okay. All right, so just give these a read. %20 of the elevators over in Indiana. So the elevator from this for this building had a chance of coming from Indiana, likely. And then we got the videos in LA. And then this will be in your guys' textbook. So a couple things they're doing here with the industry. Here's the area. Software publishers. This is 2 lists going on. So we got this location quotient, which is the fraction of the city's total employment in the industry divided by the share of national employment in the industry. So how much higher is it here in this particular locality compared to the national average? And so then that gives us a metric to kind of compare different types of clusters in different areas. So investment banking, Chicago, New York, Connecticut, shipbuilding, motion pictures, pretty high in LA still. Ophthalmic goods, what's that mean?
For the eyes?
Eyes. So it looks like we got an eye cluster going on here in Rochester, New York. Who would have guessed it? Sound recording, insurance claims. So some of these you can see they're pretty even. There's not a big dominant one like sound recording, Nashville, Tennessee, country music capital of the world, right? So now we can kind of see different ways to measure this. Wichita, Kansas, what are we doing there? Hey, look at that. Kansas made the cluster list, right? So Wichita, Kansas has been pretty famous for airplanes for a while.
What means there slide have like the share of employment? What that means? Like the equation?
This one?
No, the equation, the last slide that says that is the
That was the location quotient.
yeah.
Yeah.
The share of national employment.
So that's this one.
No, the share of national employment, what that means.
Oh, so if it was, so in this city, there's 100 people in the city and 12 people work for the, for that industry in the city. For the nation, we find that it's 5. So the national average looks like that. This one is higher fractionally, and so you do that math and you end up with a higher number of how high it is relative to the national fraction. Okay, let's see, so that was it for aerospace. So large cities, managerial, smaller cities, specialized in production. Why do you think the US has evolved this way with functional, like how the functions that go on for the company? Why these changes in functional specialization? Let's see, Carlos, number between 3 and 8.
7.
1, 2, 3, 4, 5, 6, 7. Jacob. What's your guess here? Smaller cities, production, so manufacturing, production of stuff, right? And then big cities, managerial functions. Maybe think about the people involved in managerial functions versus production. How would you describe their differences? Management versus the production line. How would you describe some differences between the people who do the management job versus the production line?
Maybe they have more education.
Okay, maybe more education, right? That could be part of it. So now let me see. I saw a couple hands going up. Lawson?
I was thinking in smaller towns there's probably a little bit more land mass to build factories and all that compared
Okay.
to cities.
So the resource of land could be part of it, Mackenzie?
That's kind of what I was gonna say, like the larger cities are managing, maybe the smaller cities to produce.
Okay. And in terms of clustering and knowledge spillovers, management functions, CEOs, MBAs, right? They can operate closer together than what the plants would be too, right? So there's probably some clustering because you have lots of multiple, like my son works for Volt Optical. They actually manufacture the thing that he does in Cleveland, Ohio, but his boss is in New Jersey, right? And so that was one thing that came to mind with my son on that one. All right, so this concept of nursery cities, again, just a different way that researchers have tried to tease out, like, why would firms move to where they do? And so 7/10 relocated from a diverse to a specialized city. Now, how would you even measure that? Cleveland versus Ottawa, Kansas City versus Minneapolis. Diverse city, what does that look like? What do they mean by diversity here? Are we talking black and white and different religions, or Jameson?
Like different, like companies, corporations, and like what's there.
Same industry or different industries?
Different.
Totally, yeah, different industries, right? So you can kind of measure the diversity level of the number of industries in a particular city or whatever. And so they're saying there's other cities that might be more concentrated in a certain trade or certain area. All right, we will call it a day there. That ends chapter 4. So I encourage you to, I'm not going to set the due date for tonight, but if you do, we can talk about it Friday, so you guys can bring me questions if you want. Chapters 4 and 5 are going to be due, so you can throw me a couple questions. I want to make sure we have enough time, which we will, for chapter 5. Chapter 5 is a little shorter than this chapter for tomorrow. So, but chapter 4 and 5 is due this weekend, so Sunday. Huh?
The review and apply.
Yes, review and apply for both chapters.
But we don't have the answers this time, the key.
No, the answers are in there, yeah. Yep, the answers are in there. So same thing. Yes?
So you were just saying that there's nothing to do with us tonight, but everything that we do is Sunday?
Yeah.
Okay, and then, yeah, I ordered the list, I ordered on there, so it was like,
Oh, Carlos did I just want to, because I guess a few people, but you can make friends, looks like you already did make friends. So make sure you get a copy or something from somebody.
yeah, I was gonna maybe like ask Jacob or something, just for like when we had to do homework, because when the fastest on Amazon I could get it was like by the beginning of February.
Let me see your books, Carlos.
Like,
Yeah.
I'm hoping that because Amazon it may come sooner, but
Yeah.
I didn't want to pay the $150 there when I could see the.
What is it, 150 in
It's
the bookstore?
$150 and it's not even a real book. It's like loose leaf papers.
Oh, the loose leaf deal?
That's
Not
why.
even like that.
No, it's like
It's not like that.
in the bookstore. He said it's like loose leaf. That's why they don't let you rent it.
Yeah,
Does it
that's what
get-
he told me too. It's 150 here, and you have to buy it from the
But it's on
person.
Amazon for like 70 or something.
Did
like
you-
that.
That was the Amazon 71.
Did you look
Yeah.
to see if how different any differences, Carlos?
No, like I don't have the
Wait.
real one to
Okay.
see.
That one's the, you got the 8th edition?
I mean,
No, you better not have. I hope.
Or the ninth?
Yeah, you have to get the
Yeah,
ninth.
yeah, that's what
okay.
that's what I thought.
Those,
Wait.
those questions look the same that you were putting on
Yeah,
the
when you
board.
say 61, I got a 61 and what's the
They're the same thing.
Yeah, one
Then
page.
what's the difference?
How much was
between-
this one?
70? No, actually was 86 with taxes and delivery.
So
Okay.
what's the difference
Was
between
from another
his
store,
book
wasn't
and
from Amazon.
your book?
I don't know. That's why I'm looking.
I swear the
Sometimes-
bookstore had that version.
Sometimes they change up
International.
like the order. I've seen this before in other textbooks. Will they'll change up the order of the question.
This is
I
the
mean,
one I ordered.
chapter 4 looks all. That's correct. Yep.
Yeah,
Is that the one that you ordered?
yeah.
Yeah.
I
Yeah.
think that one was like a long time, so I get the one that was.
And I don't know if maybe this isn't much cheaper than the regular one, but yeah, the international.
Oh, that's the difference.
So this is so what's happening here is people are defeating. Let me shut off this recording.
Oh wait, yeah, mine's the same one as his.
Yeah,
It
and I
has that
got
on
Okay.
I
top.
got a book for management.